All right, guys. So let's start in on the other terrestrial planets besides Earth, and talk about Mercury, which of course is the closest planet to the Sun. Now you might see this picture over here. Let me move this out of the way for you. Whoa, hold on. I guess I can't do that. Let me go right here, and I'll move it out of the way. There we go. So, hello. There we go. Let's move this up. That kind of looks like our moon, right? Well, it's not. It's Mercury. But it really does look a whole lot like the moon. Let me start this slideshow again. It has that same cratery surface, looks pretty dead. And in fact, it's only 1.4 times the size of our moon, so it's pretty tiny. Um, Now, because it formed so close to the sun, it really had to form from things with really high condensation temperatures. So what does that mean? It means materials that can condense even though things are very, 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 very hot. So things like iron have really high condensation temperatures. And that's what Mercury is mostly made of, which is really interesting. Now, Mercury really has no volcanism now at all. It has a small magnetic field, even though it has this really large metallic core. And that's a little bit of a mystery because remember, when we have this really large metallic core, iron core, we think maybe that should be causing a dynamo effect of some kind. It could be because Mercury rotates very, very slowly. We're going to talk about that in a bit. Mercury really doesn't have an atmosphere, but it does have kind of a thin layer of hydrogen and helium sort of hanging around. And this picture here, which I really love, again, I can't do that. Oh, it's really annoying. Okay, back to the start. So this picture down here is a picture of Mercury transiting the sun. So in other words, going in front of the sun, and you can see this little dark ball here is Mercury and how much bigger the sun is, even at this, angle. So really, really amazing picture. Okay, let's look at the kind of a comparison of the insides. We haven't talked about Venus yet. That will be in the next lecture, which will be next week. But it's really kind of striking how big the core of Mercury is. And again, this is because it had to form from mostly these materials with high condensation temperatures like iron. So it's got this really, really giant core. And you can see very different, so the differences between the four terrestrial planets. Okay, let's look at Mercury's surface in more detail. So we have these lots and lots of craters. And this big one here, again, this is that color coding we saw before, right? This elevation color coding, is this giant impact crater called the Caloris Basin. And over here, we can see little ridges and mountains right down here. Now, you might think of mountains, as we saw on Earth, as being caused by tectonic plates. But there really are no tectonic plates on Mercury. So these mountains were actually formed, these ridges here, were formed when the crust shrunk, okay, as Mercury cooled. So it's kind of like, if you leave a apple out too long, right? And again, it kind of shrinks up and shrivels up. That's the same thing that was happening to Mercury's crust. So kind of an interesting process that happened for Mercury, but it really does kind of look like this barren, surface of the moon. Now, because it's so close to the sun, when it, and it does rotate, we're going to talk about that rotation in a second. You have a very high temperature variation between the daytime and the nighttime. So day on Mercury can get up to 800 degrees Fahrenheit, and night can go down to minus 200 degrees Fahrenheit. So it's huge temperature variations over the course of a day. Now let's talk a little bit about that day. So Mercury has this super slow rotation, and that is because it is what we call tidally synchronized. So remember, we had tidal locking on the moon, right, between the Earth and the moon, where now the moon only presents one face to us because its rotation is perfectly in sync with its orbit around the Earth, right? Well, this is sort of like that. It takes 88 days for Mercury to go around the sun, but and only 59, sorry, I shouldn't really say only, it takes 59 days for it to rotate once around its axis. So it's very slow, but not quite in sync with its orbit. So we call this tidal synchronization, and in fact, it's about every twice that it's going to be present the same face to the sun. And it's got a very eccentric orbit. You can kind of see it's not circular, right? Circular would be the same distance between here and the middle and here in the middle. And you can see they're quite different, 0.47 AUs and 0.31 AUs. So it's quite eccentric in its orbit. Kind of does really look like an ellipse, whereas even though the Earth's orbit is an ellipse, it looks very, very circular. It's very close to being a circular orbit. So I thought we'd have a little story time, because one of the favorite things that I've ever read, science fiction-wise, about Mercury was written by Kim Stanley Robinson, who wrote a book called 2312. There's a whole series of them, very thick books, very, I guess I wouldn't say the most entertaining because they're quite slow-moving. But they're all about a future 2312 where man has sort of gone out into the solar system and colonized all the different places in the solar system, including the planet Mercury. So I'm going to read you an excerpt of this book, 2312, and it actually is the prologue to, I think, one of the chapters. I'm not sure, if I can't remember now if it's the prologue to the whole book or prologue to one of the chapters. So let me get to that. That is right here, and I would highly recommend this series. There's a whole big series of them about terraforming Mars and just lots of cool stuff. Okay, so here goes, the prologue. The sun is always just about to rise. Mercury rotates so slowly that you can walk fast enough over its rocky surface to stay ahead of the dawn, and so many people do. Many have made this a way of life. They walk roughly westward, staying always ahead of the stupendous day. Some of them hurry from location to location, pausing to look in cracks they early inoculated with bioleaching metallophytes, quickly scraping free any accumulated residues of gold or tungsten or uranium. But most of them are out there to catch glimpses of the sun. Mercury's ancient face is so battered and irregular that the planet's terminator, the zone of the breaking dawn, is a broad chiaroscuro of black and white, charcoal hollows pricked here and there by brilliant white high points, which grow and grow until all the land is as bright as molten glass, and the long day begun. This mixed zone of sun and shadow is often as much as 30 kilometers wide, even though on a level plane the horizon is only a few kilometers off. But so little of Mercury is level. All the old bangs are still there, and some long cliffs from when the planet first cooled and shrank. In a landscape so rumpled, the light can suddenly jump from eastern horizon and leap west to strike some distant prominence. Everyone walking the land has to attend to this possibility, know when and where the longest sun reaches occur, and where they can run for shade if they happen to be caught out. Or if they stay on purpose, because many of them pause in their walkabouts on certain cliffs and crater rims at places marked by stupas, cairns, petroglyphs, inuksut, mirrors, walls, goldworthies. The sunwalkers stand by these, facing east, waiting. The horizon they watch is black space over black rock. The super-thin neon argon atmosphere created by sunlight smashing rock holds only the faintest pre-dawn glow. But the sunwalkers know the time, and so they wait and watch until a flick of orange fire dolphins over the horizon, and their blood leaps inside them. More brief banners follow, flicking up, arcing in loops, breaking off and floating free in the sky. Star, oh star, about to break on them. Already their faceplates have darkened and polarized to protect their eyes. The orange banners diverge left and right from the point of first appearance, as if a fire set just over the horizon is spreading north and south. Then a pairing of the photosphere, the actual surface of the sun, blinks and stays, spills slowly to the sides. Depending on the filters deployed in one's faceplate, the star's actual surface can appear as anything from a blue maelstrom to an orange pulsing mass to a simple white circle. The spill to left and right keeps spreading further than seems possible until it is very obvious one stands on a pebble next to a star. Time to turn and run. By the time some of the sun walkers manage to jerk themselves free, they are stunned, trip and fall, get up and dash west in a panic like no other. Before that, one last look at sunrise on Mercury. In the ultraviolet, it's a perpetual blue snarl of hot and hotter. With the disk of the photosphere blacked out, the fantastic dance of the corona becomes clearer. All the magnetized arcs and short circuits, the masses of burning hydrogen pitched out at the night. Alternatively, you could block the corona and look only at the sun's photosphere, and even magnify your view of it until the burning tops of the convection cells are revealed in their squiggling thousands, each a thunderhead of fire burning furiously, altogether torching 5 million tons of hydrogen a second, at which rate the star will burn another 4 billion years. All these long spicules of flame dance in circular patterns around the little black circles that are the sunspots, shifting whirlpools in the storms of burning. Masses of spicules flow together like kelp beds threshed by a tide. There are non-biological explanations for all this convoluted motion, different gases moving at different speeds, magnetic fields fluxing constantly, shaping the endless whirlpools of fire, all mere physics, nothing more. But in fact, it looks alive, more alive than many a living thing. Looking at it in the apocalypse of the mercurial dawn, it's impossible to believe it's not alive. It roars in your ears. It speaks to you. Most of the sunwalkers over time try all the various viewing filters and then make choices to suit themselves. Particularly filters or sequences of filters become forms of worship, rituals either personal or shared. It's very easy to get lost in these rituals as the sunwalkers stand on their points and watch. It's not uncommon for devotees to become entranced by something in the sight, some pattern never seen before, something in the pulse and flow that snags the mind. Suddenly, the sizzle of the fiery cilia becomes audible, a turbulent roaring. That's your own blood rushing through your ears. But in those moments, it sounds just like the sun burning. And so people stay too long. Some have their retinas burned. Some are blinded. Others are killed outright, betrayed by an overwhelmed spacesuit. Some are cooked in groups of a dozen or more. Do you imagine they must have been fools? Do you think you would never make such a mistake? Don't you be so sure. Really, you have no idea. It's like nothing you've ever seen. You may think you are inured, but nothing outside the mind can really interest you anymore, as sophisticated and knowledgeable as you are. But you would be wrong. You are a creature of the sun. The beauty and terror of it, seen from so close, can empty any mind, thrust anyone into a trance. It's like seeing the face of God, some people say. And it is true that the sun powers all living creatures in the solar system, and in that sense is our God. The sight of it can strike thought clean out of your mind. People seek it out precisely for that. So great opening there, right? Really visual. It would be amazing to stand on Mercury and look at the sun, although it sounds quite deadly. Very interesting thought, right? All these people chasing the sunrise on Mercury. Anyway, so we will leave you with a question. Pause your video.